Hello, welcome. So I saw a video. I saw something. I saw something earlier today that I thought was interesting, and I wanted to talk about it. Give me just one moment. There we go. Okay. So basically, it was a geometry question on. It was a geometry question on YouTube, and I was like, oh, I should be able to solve that, right? Like I know something about geometry. So the question was something like this. Something like this. This is not the scale, by the way. Okay. Well, it looks like I have to do it right. Otherwise, or else. Okay, something like this. And it was right angle here, right angle here. Oh wow. Let's try that again. Let's give that another shot. Really should make like a square, right? Not quite. Okay. All right. And they said, okay, 3, 3, 4, 5. What is this? Right? This was basically the question. Okay. And I thought this was an interesting question. And I said, okay, well, you know what you can do? You can take this. This is a 3, 4, 5. Right? Pythagorean theorem. We know that. And this is another triangle. And that's that is, let's call that y. Y is going to be the square root of 41. The reason for that is, getting a little ahead of myself, but it's 4 squared plus 5 squared, again, Pythagorean theorem, is y squared. So that gives us 16 plus 25, which, wow, that is some fantastic chicken scratch. Let's go a little slower here. That's 41, which is y squared. And so y is square root of 41. Now we have 3, 4, 5. Now what you can do is you can actually rearrange this to be the following. Look like the following. You ready for this? This is kind of neat. It took me a while to think about this, realize this. Okay. 3, 4, 5. Let's right angles here. Okay. And then you can say, okay, so here's this triangle. Here's that triangle. So this is, oops, this is y. And what's interesting is this is 5. What's interesting is that you can actually take this 3 and this 5, and you can make a box out of this. Let's use red. Or let's use red. Let's use green. And you could say, let's go ahead and extend that. Make a nice box here. And what you realize is that this picture, this is 5, this is 3, and these are 4. Say, oh, that's interesting. But not only that, you could draw this line here, from here to here, right? And you'll notice that is exactly this line from here to here. And not only that, but that line, that red line, call that Z, is exactly Z squared is 3 plus 5 is 8, 8 squared, plus 4, 4 squared, because this is a rectangle. Or not a rectangle, yeah, it's a rectangle, and it's also a right angle. So now what you can do is you could say Z is, this is 64 plus 16 is 80. Z is the square root of 80. And now you can say, oh, that's interesting. Actually, it didn't matter what Y was. I thought that was a 4, 5, 6, but 4, 5, 6 is not actually not a Pythagorean triple. But yeah, 3, 4, 5 is the Pythagorean triple. So that actually means that now this red line, and this is a triangle, 3x, and this red line, where Z is square root of 80, means you've got x is going to be x squared plus 3 squared equals 80. I already said this is square root of 80, this is Z squared. So if you square it, it's going to be 80. So that means that x squared is 80 minus 9, which is 71. So x is square root of 71, which is not an integer. So this is not a particularly nice number. But that seems to be the solution to this question, this problem. And it's pretty neat. I thought this was a nifty question, nifty problem. Now, is this shape even possible? I have no idea. I couldn't tell you. But in theory, if it exists, then that would be, if it could exist, then that would be the length of this line here. Also assuming one more thing, that this is also a right angle, which is not necessarily a right angle, you know. But if all things were true, right? Right angle here, right angle there, 3, 3, 4, 5. You'd have 3, 4, 5 here. And it really, actually wouldn't even really matter what this length and this length is, right? Because we could just make a box out of this kind of piece, create this kind of box. Oh, that's a nice box. Do this kind of a thing. Create this box, and then we get that line. And that obviously that's a rectangle, and then that line splits that rectangle into two right triangles that are equal. And then you can use Pythagorean theorem to get that length, and then you can use that length to figure out what this length is supposed to be, also using Pythagorean theorem. So that's fun. So that was kind of nifty. I saw that online, and I was like, I was thinking about it. I was like, like how many different things you could try to kind of figure, because I was going to try to figure out what this was and figure out what that was, and then use that to try to figure out what this is. And I was trying all kinds of different things, and not too many different things, but I realized like, oh, this is actually like an easy question if you see it, a relatively easy question if you see it. So kind of neat. Hope that was interesting. That was interesting to me. This problem really tripped me up, but yeah, it was on some YouTube video, and I was like, oh, let me think about that for a minute. I should be able to solve this, right? Like I graduated high school, like I should be able to solve this. We give it a shot, see how we do. So yeah, thank you for watching. I'll talk to you soon. Take care. Hope this was enjoyable.